Today we're starting a new section, actually a new chapter. We are going to still be doing hypothesis tests. So these problems will feel similar, but we are going to do them now with two sets of data. So we're pulling two samples and we're comparing them. So first thing we want to know is if we pull samples, we can do that in one of two ways. One type of relationship between samples is called independent samples. Independent samples. These are what you would expect, samples that are unrelated. Okay. So I'm just going to go in, we're testing what's the average height at our college, and I'm just going to pull a random sample here, and then I'm going to pull a different random sample here. They're not related in any way. Dependent samples is where there's a correlation between the samples. So let me give you some examples. It could be that there's a correlation, like I'm going to pull a sample of mothers and then their sons. So like there could be a relationship in that way, but it also could be that I'm going to pull one sample and I'm going to test them in something, then I'm going to do something to them and then test them again. So for example, if I'm testing a workout machine, so I might pull a sample and test people's resting heart rate at the beginning of this experiment, and then I would have them use my exercise machine for a month, and then I'd test their resting heart rate at the end of the month. That would be a dependent sample too. So dependent samples don't have to be two different samples. They can be if they're related, but they could also be one sample that's a before and after. Most of the time in the book, the problems of this book, they're that scenario where it's one sample and it's a before and after, but it doesn't have to be that way. So what we're looking at in 8.1 are independent samples. And what we're comparing is their means. So the two different sample means. All right, so let's jump to a problem. So a guidance counselor claims that high school students in a college prep program, so this is our one kind of group, have higher ACTs than those in a general program. All right, so those are kind of our two groups that we're looking at, the college prep group and the general program group. Now you can assign either, you can address them in either order, but you need to be consistent with how you do it. What I do in a problem is just whichever one comes first is 1, and whatever one is stated second is 2, and then I leave it that way for the problem. But you can switch it if you want, but then it has to be switched for the whole problem. Up to you. So we have some data here. So mean ACT scores for this sample and this sample. So I've got two kind of populations. I'm going to make a claim and I'm going to pull a sample from both. So let's jump down here to the claim. At alpha equals 1.0, can you support the guidance counselor's claims? Oh, he claims that the college prep program has higher ACTs than the general. So my sample 1, so my mean 1 is bigger than the mean 2. So this is how your claim is going to look in chapter 8. You're going to have, instead of just one mean and a number, you're going to have 2 and they're going to be compared. So this is saying the first group, the college prep group, the one I labeled number 1, has higher scores. So that one's bigger than the general program. That's my mean 2. And that's the claim. And that's really about where the differences end. We're going to do very much the same thing. Your complement is going to be switch, add the equal sign. H naught is going to get the equal sign. HA is going to get the other. Your picture is going to be dictated by HA. So in this case, HA is pointing to the right. So this is going to be a right-tailed test. I've got an alpha value of 0.10. So if we want to, we could find our critical value, and we're back on means. So this is a z-score now again, because we're looking at means. Means are always z-scores. So this is going to be a z-critical. So let's do that really quick. My TIs, you're going to go second distribution. You're going to do your inverse norm, and you're going to enter 0.9. Why? Because inverse norm, our inverse functions always measure from the left. So in order to get this value right here, I've got to enter 0.9, that area from the left to that line. 0.1 will give you the wrong answer. My class calc people, we're coming over here to stat, to distribution and plot. We're doing our normal distribution. Mean is 0. This is for TIs 2. Mean is 0. Standard deviation 1. Standard normal curve. We are hitting the stat again, distribution plot, and we're doing this dot inverse, and we're entering 0.9. So this is going to be our critical value, 1.28. 1.28, that's our critical value right there. And so our rejection region is going to be any z-score that's bigger than or equal to 1.28. Okay. That's our rejection region. Now let's do our hypothesis test. So this is going to be a 2-sample z-test. So we're back. It's like we're starting chapter 7 over with our progression. It's going to be a z-test, a t-test, a proportion test, only now it's 2 samples instead of 1. Okay. So again, it's a z-test because sigma is known. That's what dictates what kind of test you've got right here. Population standard deviations are given right there and right there. That's what classifies us as a z-test. So I'm going to go onto my class calc. I'm going to come down here. I'm going to go into stat, and I'm going over to my tests, and I'm looking at 2-sample z-test right here. And so what you'll notice is it's exactly the same as the 1 sample, only you've got to enter all 2 sets of data. So you need both sigmas, your sample mean, sample size, sample mean, sample size, in that order. So I'm going to first look for sigma 1 and sigma 2. So this is going to be my population standard deviation of 4.8 and 5.4. The next thing I'm going to look for is my sample 1 mean and size. So that's going to be my sample size for my first group is 49, and I've got a 22.2. Okay, and then the last 2 things are the sample mean and the sample size for the second group. So my second group has 44 students, and it's got a mean of 20. Okay, hopefully that I entered that data right. Again, I need to pick my tail. I've got a right tail test because of my HA. So my p-value is going to be let's call it 0.02. Okay, so here's my picture. P equals 0.02. That's a horrible color to see. Sorry. P equals 0.02. Okay. And why am I putting it there? Because 0.02 is smaller than 0.1. So that means that it's deeper in the tail there. Okay. If you want, you can look, if you're doing rejection region method, you can look at your z-score. Your z-score is 2.07. And that is clearly way up here, 2.07. That is higher up than 1.28. So either way you look at this, we are going to reject H naught. Again, we don't assume the claim is right or wrong. We assume H naught is true. And then we either reject or fail to reject that. So this is saying, here's my claim. And I just said, hey, the opposite of my claim is not true. That means that my claim must be true. So let's look at our chart. My claim's HA. Whoops, went the wrong way. Sorry. My claim is HA. I'm going to reject H naught, and that means that there is enough evidence to support the claim. So there is enough evidence to support the claim. All right. And that's it. Now, what if there's data? Guess what? It's not really different. You're just going to hit the data button on the 2 sample Z test. Let's run through this really quickly, practice writing our claim. So a sociologist claims that children aged 16 to 17 spent more time watching television in 81 than they do today. So I'm going to take my 1981 sample as 1, my today as sample 2. So the claim is that they spent more time back in 1981 than they do today. So this is my today, and this is my 1981 group. Okay, we're comparing those 2 samples. So this is going to be my claim. This is going to be my HA, my complement, flip the sign, put the equals on, and that's my H naught. This is going to be a right-tailed test again. Okay, my alpha is going to be 0.05. 0.05. And this time I'm not going to do the critical value. I'm just going to compare the p-values. So you're going to enter this data into your calculator. Now, for my TI people, you're going to hit stat, and you're going to go edit. And now you're going to take, you've got L1 and L2. You're going to enter your data, your first column of data in L1, and make sure that your sample 1 is in list 1. And your sample 2 is in list 2. So keep those in order. Don't flip them around. And so you're going to have two data lists. For my class calc people, you are going to enter 2 data lists like this. I did this before I started. So I've got list A. Now remember, you have to name it something, A, and you have to use square brackets. So there's my list, and then next line I name it something different. So I named mine B. That's a tap hold on the 8. Okay, you can name it anything you want, but they have to be different. So that's my A and B. Okay, and then for my class calc people, oh, and I didn't do TI for this, so we'll jump over there. Sorry about that. Stat, we're going to go to test. And we are doing 2 samples Z test. And now instead of stats, I'm doing data. This is actually a bit easier with filling in the blank, because now all I need is sigma 1 and sigma 2. So let's check it out. Here's my problem. So I've got standard deviation is 0.6 on my first one and 0.5 on my second one. So I got 0.6 and 0.5. And then it's just asking me what are your lists called? So I've got list A, and then I've got list B. Picking my p-values to be a right tail. So I've got 0.004. So here is my p-value 0.004 because p is smaller, so it's more in the tail. If you did a z critical, it would be a bigger number than your test statistic would be a bigger number than your critical value. So we are going to again reject H naught. HA is the claim. So that means that our conclusion is the same. There is enough evidence to support the claim. Okay, for TI people, you probably guessed this already. You're going to find your two sample Z test. You're going to hit stat. You're going to go over here to tests. And it is going to say, mine is the third option. It says two sample Z test. That's going to be your guy. And you'll get a list very similar to the ClassCalc people asking you to enter. You choose at the top either data or stats, and then you enter all your information. There is a place on this where it asks for frequency. Just leave those alone. Okay, those don't apply to you, but fill in everything else. And you gotta push your down button to get all the information in because there's several lines of it. One last thing I want to say for this section, it's a notation issue that you'll see in your homework. I write my claim this way, right here, where I'm comparing one mean to the next. And it doesn't matter which way you write that. You could write, like, let's say your claim was that the first one's bigger than the second one, or the other way around. It doesn't matter what that sign in the middle is. Sometimes what we do with this is we do an algebraic manipulation with this sentence. So let me explain what this is. You may remember in Algebra 1, if you have an equation like this, something like this, that you can take this 3 and you can move it over to the other side by doing the opposite operation. So since that's a +3, I could subtract 3 from both sides, and that moves it across the equal sign. Well, this is an equation of sorts as well. We call it an inequality, but you can also move things across this. And so what sometimes you'll see the book does is it takes this second mu, so it takes this right-hand side and it moves it across this way. And the way that that works is by subtracting this from both sides. Now, what that does is these guys cancel because the 1 and the -1 is gone. And these two sit side by side. So it looks like mu1 minus mu2. And then our sign is still here. And what I'm left with on the right-hand side is 0. So that's another way of writing it. You do not have to write it that way, but you might see that notation in your homework. Just know that that's the same as your original claim. It's just that they've moved the one thing over, okay? And sometimes they take this and they note it as mu d, which stands for the difference of the means. And again, not necessary for you, but just to know that all of these things are the same. So it's just a different way of writing your claim. So don't worry too much about that. If you see that, and if you have any questions, let me know. That's it for this section. Hope you guys have a great day.